Okay, so we were talking about the different kinds of solids. So we talked about the polyhedrons, where the prisms and the pyramids, and then we talked about that the non-polyhedrons are the cylinder, the cone, and the sphere. And I'm not going to read you the definitions of each of these. I think by now you probably know what these three-dimensional shapes are, but if you wanted to read the technical definitions, you certainly could. Okay, so here we go. In example 2, determine whether whether the solid is a polyhedron. So that's number 1. Number 2, then identify the solid. So which one of these guys from above is it? And if it is a polyhedron, number 3, name the bases, faces, edges, and vertices. So let's take a look at this first one. So first of all, do we think this is a polyhedron? I would say yes, because it doesn't have any circles on the bottom or the sides or anything. So solid, so this is what? A pyramid. That would be its last name. And remember, we have to look at that base to determine what kind of pyramid it is. So we got to count the sides. 1, 2, 3, 4, 5. So 5 sides, so we would call that a pentagonal pyramid. Okay, the base is a pentagon. What kind of faces do we have, though? I hope you're thinking about that those faces are triangles. We won't list them all. The edges, there's a bunch of them here. We've got AE, ED, CD, BC, AB, FA, FB, FC, FD, FE, and FA. Those are all edges. And then next are all the vertices, which is a little bit easier. The vertices would be what? A, B, C, D, E, and F. All right, so take a look at the U-Try. Give your best guess as to if this is a polyhedron, what kind of solid it is, what kind of base it is, anything you can name on it. And then we'll come back and take a look. Okay, so this is not a polyhedron, and we know that because of this circle base here. Even though it's the top in this scenario, we still call it the base. So the base, just for practice, would be circle R. You could do the circle symbol with the dot in the middle, R, and then the vertex, it doesn't have faces or edges, but the vertex would be point S. So you didn't really have to do those bases and vertexes. I think it said just if it's a polyhedron, but just so that you kind of get the idea of what you're looking at here. Okay, so let's go look at the next page, and this talks about the word regular polyhedron. We've seen that word regular before. That meant all sides, all sides congruent and all angles congruent. Same idea here. A regular polyhedron is a polyhedron in which all of its faces are congruent. All the sides are the same exact size, exact same shape, and all of the edges are congruent. Note that these are sometimes called the Platonic solids, after the Greek philosopher Plato, who used them extensively. So here's some examples of the Platonic solids, of some regular solids. We've got the tetrahedron, which is a fancy name for a triangular pyramid. You've got the hexahedron, which is basically a cube. You've got the octahedron, the dodecahedron, and the icosahedron, each of which are made up of congruent shapes. So just kind of fun. So this is 4 sides, tetra meaning 4, hexa meaning 6 sides, octa means 8 sides, dodeca, you might remember, is 12, icosa, I think it's 21. I'll have to look that up. All right, so what you're going to do now is there is a little video on Haiku that is going to explain cross sections, and then we'll come back and finish the notes together.